scientific platform. We are still on applications of differentiation, but we are focusing on small changes. Small changes. So this is our seventh question on small changes, how to determine small changes in a particular quantity as a result of a change in the other quantity or variable. All right. So we have our seventh question here, which is a percentage error made in measuring the radius of a spherical bowl is Z%. All right. So it means when a person was measuring the spherical bowl, the radius of the spherical bowl, the person made an error and they calculated a percentage error and they had it to be Z%. All right. Now we have to find the percentage error in measuring its surface area. So it means the problem here involves a surface area and that of radius of a sphere because of spherical bowl. So it means we are going to focus on sphere. And we have two areas, surface area and that of its radius. Okay. So let us start work. A solution. So when it comes to surface area of a sphere, we have the formula to be 4 pi r squared. So this is the formula for calculating surface area of any spherical shape. All right. Now we were given the percentage error in measuring the radius of the spherical bowl. Right. So we know that percentage error in any given quantity is equal to error divided by the original value, that is the actual value or the original value times what? 100%. All right. So we're given the percentage error to be Z%. All right. So we are going to now find the error here is the same as the change. Maybe we're supposed to get the radius as 5 centimeters, but instead of 5 centimeters, you obtain it to be 5.2. All right. So the error committed over there will be 0.2. Okay. Because instead of 5.0, you had 5.2. So the difference becomes 0.2 and that becomes the error. So the error is the same as the change. Okay. So we have our error here divided by the actual value of the radius. Okay. So we know that the actual value of the radius, we are going to use R because we don't know it. 10 times 100 what percent. Okay. We were given the percentage error to be Z%. So we have equated it to the formula. So we are now going to make R a subject. So we can divide through by, or we can multiply through by 100 so that we can get rid of the percent sign. All right. So we are going to get Z is equal to the error committed, which is the same as the change. Okay. Divided by the actual radius of the sphere times 100. All right. So here we are going to get our Z to be equal to the error times 100 divided by what? R. Now, the error is the same as the change that has occurred in the radius. Okay, so our error here is equal to the small change that has occurred in the radius. Because let us assume that we're supposed to measure the radius of the sphere, and the right radius is supposed to be, or was supposed to be 5 centimeters. But instead of the 5, you had the result to be 5.2, right? So you have committed an error. So the error will be the difference between the two dimensions or the two results of the radius that you have obtained. So it's the same as the change that has occurred in the two radii. Okay, so Error here is the same as the small change that has occurred in the error. Sorry, in the radius, sorry. So we are going to get Z is equal to small change in R times 100 divided by what? R. So we cross multiply, we are going to get Z R is equal to small change in R times 100. So you cannot divide through by 100 because we want to make the small change in R the subject. So divide through by the coefficient of the small change in R, which is 100. So 100, okay. So you are going to get Z R divided by 100 to be the small change that has occurred in the R, which is the same as 100. You can rewrite it as 0.01 multiplying ZR, okay, the same as it is equal to the small change in R. All right. Now we are to find the corresponding percentage error in measuring each area. Okay. So we are going to determine the area of a sphere, which is the total surface area. So the surface area, you know it to be 4 pi r squared. So we have to, I'll use S to represent the surface area. Okay. So I'll now differentiate my S, that is the surface area, with respect to the radius. And this will give me a result of 8 pi r. Okay, result of 8 pi r. And we know that the change in X with respect to the change in the surface area with respect to its radius is approximately the same as the small change in the surface area divided by what? The small change in what? The radius. That is the change in the surface area, the small change in the surface area as a result of the small change in the radius of that same object. So we know our dx dr to be 8 pi r, okay? So we are going to equate 8 pi r to our small change in s, our small change in s divided by our small change in r. But we know our small change in r to be 0.01 zr. Okay, so we are going to substitute it. So let us cross multiply first. So we are going to get, you can cross multiply. So this multiply this and this also multiply this. So we're going to get 8 pi r multiply small change in r equal to the small change in what? S. Okay. We know our small change in r. Let us go back to be 0.01 ZR. So we are going to substitute the value of small change in r, which is 0.01 ZR. Okay. All equal to the small change in what? S. So we continue. We are going to now multiply 8 by 0.01. So let us do that and see what we'll be getting. So because we have, it is the same as we have the 0.01 is the same as 1 divided by 100, okay? So it's the same as this becomes 8 divided by 100. So we are going to get it as 0.08, okay? 0.08. Then pi, we have pi here, okay? Then we have z also multiplying the z over here because of this z. Then we have r multiplying r, then z r squared. So this becomes the small change in the x, okay? Now we have to find, this is the error that has occurred in the x. That is the total surface area, the error that has occurred in it. But we have to find the percentage error that has occurred. So you know that percentage error will be equal to the change in the surface area over the surface area times what? 100%. Okay. So you are going to get a change in the surface area to be 0.08 pi z r squared divided by the actual total surface area, which is, you know, total surface area of the sphere to be 4 pi r squared. Okay, know it to be 4 pi r squared. So now we need to just simplify and get our result. So here we are going to get it as, so we have pi here, this pi will divide this, okay, and yet we have, right, I didn't bring my times 100%, good, okay, so the square, r square also cancels this, we are left with 0.08 z times 100, okay, write it well, times 100, or divided by 4%, okay. So this will give us 0.08 times 100 will give us 8. So we are going to get 8z divided by 4%, okay. Then here we are going to get a result of 2z%. So we conclude that the corresponding percentage error in measuring the ceiling, oh, the brain is tired. The corresponding percentage error in measuring its surface area, or that is the percentage error in measuring the surface area of the spherical bowl when an z% error has been committed in measuring the radius is 2z%. Okay, so it means the percentage error in measuring the surface area of the spherical bowl will be equal to 2z%. Okay, so this is the answer for the given, or this is the solution to the given problem. Thank you for watching, and I hope you really enjoyed the lesson. Please do not forget to share my videos on other platforms for others to also watch and subscribe to my YouTube channel. Thank you so much. Bye.